Again, many different ways to do the same thing. So if you do it a different way, that's fine. So show that. So I'm going to start on the, it's easier to start on the right hand side. I think you guys can do this, no problem. So x plus 1, lots of all of that stuff has to equal, hopefully when we expand it, the right thing. So if I times first everything by the x's, I got x cubed, 2x squared, 2x. Now I times it all by the 1. So I'm going to get x squared, 2x, and 2, and I've still got an x minus 1 at the end. Alright, so I've only got an x cubed there. The squares, I've got 2x squared, 3x squared. The x's, I've got a 2x, a 4x, a 5x. And the constants, I've got a 2 minus 1 is 1. So that's good, that equals our left-hand side, so we're all good. Alright, so we're going to use that. Alright, so let's use that. When it says hence or otherwise, hence is probably the easiest way to go. So it's kind of helping you along. So if I put that that in what we just did, so if I put that in here, now again you'll see this done in different ways. So I'll just do that. I'll put that bit in, and then I'll put the x minus 1 separately. There we go. Plus 2x plus 2 dx. There we go. Alright, so I'm going to do it in 2 parts. And if I might get this ready so we've got it. So I'll make u squared again equal x squared, 2x and 2. So everything under the third. Then 2u du is going to be 2x plus 2 dx's. Okay, so if I look at the first part of the integral, what I can do is put a half out the front and put a 2 in front of that x minus 1. That gives me 2x minus 2. Is that what I wanted? That is supposed to be a plus. Yes. That is supposed to be a plus. Now it gives me the 2x plus 2 that I wanted. So that's just by putting the half out the front. And then I've still got, well, actually, let's do, this is the power of 1, and the bottom is the same thing to the power of half. So 1 minus half is a half. So maybe I'll just put the square root part up here, like that. And this part also I might get the 2x there, and I want a 2 as well. So that'll be what we normally get. And then you can see there that I've added 1, but I actually want to subtract 1. So to balance that, I've got a minus 2. So minus 2 lots of dx on the square root. I'm going to complete the square while I'm at it. All right, so looking at all that, if I use my u's, this whole part here is du, and then I've got u. So I've got u du here, and if I might change the limits this time. So if I sub negative 1 into my x's here, you can see that negative 1 squared will be 1, and then I have negative 2 plus 2. So I'm just going to get 1. Square root of 1 is 1. So 1 for the bottom. If I sub zeros in, I'll get 0, 0. I'll get a 2. Square root of 2 will be my top limit. All right, so that's just using u's. If I look at the second one, I know I'm going to get plus half. I'm going to get 2u du on u, and we know that's going to cancel and that's going to cancel. And now, since I've put my u limits in, I might as well put them in here as well. And the last one, minus 2, it's one of those funny ones because it looks like it's inverse tan, except it's got the square root. So we're dealing with that log. So we've got log of, we're going to have the x plus 1, and then we're going to have everything under the third. X plus 1 squared plus 1. And that is our, still in terms of x's, so I could change it to u's, but it's easier to keep it as x's there. All right, so having done that, let's subtract integrate and sub in. So we're going to get here an x. Now, did I stuff up here? Yes, I did. Did I? So the 2x plus 2 dx is 2u du. See that? Oops. That 2x plus 2 dx, which I underlined over here, is actually 2u du, and I'm going to put that du over here, 2u du, and then this part here is u. So actually it should have been 2u squared there. I apologise. Okay, so I've actually just got the integral of u squared, which we know is u3 on 3. So apologies, I hope you saw that. And you were wishing for me to see it. I saw it. All right. And over here, hopefully this one's right. We've just got the integral of 1 du, which is u. And that's between 1 and root 2. And then over here, I'm going to sub in 0 first. So I've got 0 for x, which is 1, plus, and 0, 1 squared is 1 plus 1. So I've got root 2. Excuse me. Minus log of, sub in -1, now I've got 0, -1 is 0 again, so I've just got root 1, which is 1. Nice. All right, let's try again over here. So here I'm going to have, let me just move it up a bit. Here I'm going to have 2 root 2, because I've got root 2, root 2, root 2, so 2 root 2's over 3. I might just keep that third right out the front. 2 root 2 minus 1, and here I'm going to have root 2 minus 1, and then minus 2 log, so it's just going to be 1 plus root 2. There we go. Alright, so make this look a little bit nicer here. So I shouldn't have kept that there, it's easier for me to, 2 root 2, so that was 2 root 2 on 3, and this was 1 on 3. Alright, just because I can put my root 2's together. So if I make them all on 3, that would be 3 on 3. And of course 1 is 3 on 3 there. So the root 2's, I've got 2 root 2 plus 3 root 2 on 3. So that's 5 root 2's on 3. And I've got negative a third and a negative 3/3. So that's negative 4/3. And I've still got my 2 log 1 plus root 2. Alright, so putting that all together now, I might keep the third out the front, it looks nice. 5 root 2's minus 4 minus 2 log 1 plus root 2. And actually that was a show that, so did we get it right? Yep, we did. Excellent.